In this video, we'll continue talking about financial options, and we'll spend just a brief moment talking about put options, the opposite of a call option, and then we'll talk about a pricing mechanism to help us figure out the value of what an option should be worth. So a put option gives the holder the right to sell a share at a specified price on or before a particular date in the future. So essentially, without getting into a lot of detail, the formulas are very similar, except they're backwards, right? So because you're thinking of the opposite type of a transaction. In this case, if you buy a put, you want the price to go down. So if you kind of think about this, if you have the right to sell a stock for $50, you could sell the stock for $50 anytime you want to in the next 30 days. What if the stock price goes to 30? Then you have the right to sell this stock for 30. So again, your profit is $20 because somebody placed a bet with you and said that that was not going to occur. You win, so you're going to end up having profit. So if we look at the strategy of how this works with a graph, here we have an $81 stock price, exercise price is $75, and the premium is $4.20. So again, if you buy the put, you have to pay $4.20. As long as the stock price does nothing, right? As long as it's above the strike price, you're going to lose, and you would lose that $4.20. But when it gets to $75, and if you look here, here's a $75 right here, you can see that the value of the option is zero there. But your profit is a negative $4.20 because you paid the premium. As the price goes down, the value of the option goes up, but the premium you paid is constant. So that means you'll start making profit. And of course, until the stock price gets to zero, so you see here, right? There's zero value here, zero profit here. You start to make money here, but eventually if it goes to zero, you would have the maximum value or profit that you could make. Now, if you sold this option, the exact same thing as with the call is true. You earned $4.20. That's yours. It's paid up front. And as long as the stock price does not go down below this profit margin, this profit point, you would make money. Anything below that, though, if the stock price goes below that, you have the potential to lose. Now, you do have a limit on how much you can lose, but it has the limit is it could go to $0, which then you would actually, in this case, you could lose as much as $75. So if you kind of think about this, these break-even points, right? It's the exercise price plus whatever the premium is. So in this case, if the stock price, we're talking about a put, so it's the exercise price minus the premium. So if the exercise price minus the premium, 75 minus $4.20, so if it goes to $72.80, you would break even. Anything below that, then if you wrote the option, you would be losing money. If you bought the option, in this case, you would be making money as the stock price goes down. So again, I don't want to spend a lot of time talking about the strategies here. We're trying to understand how these derivative securities work. So next, we have a pricing model called the binomial model. So let's take an assumption and just work our way through this model to try to see how we can use it to determine the value of the option. So we have a stock that is a price of $27. We predict that the stock price can either go up by 1.41 times or down by 0.71 times. So the new price can go to 27 times $1.41 or 27 times 0.71. We'll do that math here in a second. The call option has a half a year till it expires. Exercise price is $25, and we have a risk-free return of 6%. So let's see how this binomial payoff might work. Stock price is 27. We predict that the stock price could go up by 1.41 times. So that means it could go up to $38.07. So what's the option payoff? Remember our formula. It's 0, or if the price minus the exercise price is positive, then it has value. So in this case, $38.07 minus the $27 strike price would give us this $13.07. Down below here, again, it should be $25, right? Minus 1 gives you $13.07. My fault. The other opportunity says that the stock price could go from 27 to 1917. So 1917 minus 27 is negative. So the value of the option here is 0. So the stock price is either going to be $38.07 or 1917. The option is going to have a payoff of $13.07 or 0. So let's work our way through and think about how this might work. We want to create a portfolio that's going to create a risk-free opportunity. How many shares of stock do we need to buy to create an opportunity where these two things would be equal? So if the stock is up, the value of the portfolio is the value of the option times the number of shares. If it goes down, again, it's the value of the option multiplied by the number of shares. So let's put this into the mathematical model. We want to solve for NS. So that algebra works out. You don't have to do the algebra unless you have nothing else to do. If you take the higher call option minus the lower call, 1307 minus 0, and divide that by the price differential, $27 times the difference, right, of how it went up, you would need to say, we would need to buy something, 0.6915 shares of stock. So if you buy 0.6915 shares of stock, you would buy a risk-free portfolio for this particular option. Now, this is what's referred to as a hedge portfolio. So let's see how that works out. If you look at the stock, if the stock goes up in value, it's N sub S, the number of shares times the price. So again, it's 0.6915 times the stock price of $38.07. So it's $26.33. And if you remember back here, we said that the call option at the upside is $13.07. So if the stock price goes up, you would have a value or a payoff of $13.26. In addition, if the stock price went down, you do the same math. Again, we would end up with $13.26. So in this case, by buying that hedge portfolio, 0.6915 shares, that would create a situation where no matter where the stock goes, we would have an equal payoff by the portfolio. So we need to then, since that is the value a half year from now, we have to find the present value of that. So we need to find the present value. How do we do it? We know N is a half a year times 365 days. We have to convert everything to days. The interest rate is 6%. Again, divided by 365 days. Payment 0. The future value here is negative 1326 because we want to know how much we would want now to give up the future value of that. So the present value of this calculation is $12.87. So what does that tell us so far? Right? This is the present value of that potential future portfolio. So since this portfolio is riskless, right, the value of the portfolio equals the present value of the riskless payoff. By definition, what's the value of the portfolio? N sub S times P minus the call value. That's the value of the portfolio. And we've solved for the value of the portfolio, and we know what N sub S times P is. So again, if we do this math, right, so it's 0.695 shares times a $27 stock price today, minus, again, this is the present value of the payoff. We calculated that at $12.87. The value of this call is $5.80. Now, if you use there is a spreadsheet that's available. Again, you plug in the information that you need, and then you find out the what? Here's the value, $5.81. So apparently the math works and the spreadsheet works. So that's how you would find the value of a call. Now, how could you use that? What if the option is not selling for that, but the option's actually selling for $6? So if you could sell it for $6, you could buy the option for $5.80. Buy it for $5.80, sell it for $6, you make 20 cents. And if you're writing the option, you get this $6 up front. The $5.80 is what you'd have to spend to get the option. So every time you would sell an option, you'd make 20 cents. And you wouldn't spend any of your own money. This is what's referred to as arbitrage, right? Assume you would want to do this, and so let's say there's typically these are, when you buy a contract, it's for 100 shares. So you have 100 shares times 20 cents. So every time you sell one of these contracts, you make 20 bucks. And it didn't cost you anything to do that. How many of those do you think you could try to do in a day and you'd never lose money? You would always gain $20 every time you did a contract. That's what's referred to as arbitrage. There's no risk. And of course, what would happen is something is mispriced. It's either the stock or it's the option, right? So we're assuming in this case that the stock is mispriced, and you can make this arbitrage profit. Buy something without using any of your own money, and yet make profit every single time without the chance of loss. So that's what's referred to as the binomial model. Talk to you in the next video.